Okay, we are learning control structures. Next slide.
Okay. All right.
So quick recap of last week. So you can output to the console using print statement. There's 3 types of variables, which is int, which is a whole number, string, which is a word, and a boolean can be true or false. You get user input with the input statement, and you can put a string between the brackets to have a custom prompt. And to do math with it, you have to put it in between the int statement. So you can do math with that follows bedmass, and you can comment using an octothorpe or a hashtag. Next slide. So control structures tell the computer what to do, what not to do, how many times to do it, when to stop, and all based on the information it has. So some examples include if statements, for loops, while loops, and etc. And right here you can see a kind of an example of one. So it checks if your mark is under 50%, and if not, it does something, and if it is, then it does something else. Next slide. So booleans can either be true or false, and they're basically like statements comparing two things, and we can compare those things using operators. So there's greater than, less than, equals to, which is 2 equal signs, not 1. Exclamation mark equals to is not equal to. Then there's greater or equal to, and less than or equal to. So if you take a look at these booleans here, so you can like kind of guess what'll output true or false.
Mm-hmm. Yeah,
so,
let's just do these in like order, and then we can use like the reactions in the chat or like your reactions.
Okay, so Boolean 1, react yes if you think it'll be true, and the X no if you think it'll be false.
Yeah, so like is 2 greater than 3, guys? Okay, yeah, oh yeah, you can use the chat as well. Yeah, so actually wait, yo Eddie, use the annotation feature and then write like true or false.
Okay.
Can you do it?
The answer is
Oh wait, no.
false. Wow.
Guys, don't annotate. Just Eddie, okay?
Oh wait. Okay, looks like most people guessed no, so good. Okay, Boolean 2, true or false?
That one is 2 is less than 3, so is 2 less than 3? Okay. Yes, that is true.
Yeah. Boolean 3 is 2 equal to 3. Difficult one.
It's actually kind of tough though. You know, you need calculus to derive that. Okay, so it looks like people said no. Which, great job. Oh yeah, and just to clarify this again, so for comparison operators, notice that the equal sign, this is 2 equal sign, not just 1. So that means we're not actually like, 1 equal sign is just like initializing it and like declaring a value. So like Boolean 1 is equal to true, right? But when we want to compare two things and see whether they're equal to each other, then we use 2 equal signs. So it's kind of like whether 2 is equal to 3. You can think about it as like that.
Okay, so Boolean 4, 2 is not equal to 3.
Yeah, so exclamation mark equals means not equal to. Like if you see right under the equals, exclamation mark equals means not equal to. So if 2 is not equal to 3, then that will be true, as Eddie just wrote.
For Boolean 5, is 2 greater or equal to 3? Yep.
Yeah, so that is not true.
Boolean 6, is it less than or equal to 3?
Not true.
Yeah. So Boolean 7, we're comparing strings. So, but it's still kind of the same concept.
So like, is like these 3 letters, car, equal to the same 5 letters as truck? That is a no, right? There we go.
Yeah. So for 8,
That's actually the hardest one to have here.
Yeah.
So is true true or is true false?
Turns out it is actually false. So trick question there. Just kidding. It's true.
Right. All right. So why are we learning about these operators? Well, actually, if we just went back to the last slide, actually, wait, here. So, oh wait, they stay.
Yeah.
Right. Okay. So if we go back to the last slide here, it says if we have a mark under 50%, then if this mark is over 50%, then it's no. And if it's above 50%, wait, hold up. No, okay. So we're asking the question, is our mark under 50%? So if our mark is not under 50%, it means that it's greater than or equal to 50%. And that means we passed, right? But if our mark is under 50%, that means we didn't pass, and that means we failed. And this is what these comparisons are used for. So if we want to see if we passed or failed, then we can use these operators for that. And that's exactly what we're going to do right now. So yeah, this is like the actual answers. So in case for people who like didn't actually come. So now we're just moving on to our first concept, which is if statements. So what if statements are is they basically only perform actions if certain conditions are met. And the format in which they're written is if a certain Boolean is true, then code. So let's actually move to here. Oh wait, shoot, I need to log in. Damn it. All right.
Albert's account exposed.
Bro. No, I used last. Okay. I'm just gonna make a new replit and make it Python. Wait a minute. Python. All right, we'll name it that. Static query units. Oh, you guys know my email now, rip. That's tragic. All right. Okay, this is a good font. Wait, can you guys see this? It's already like the biggest font I can do though. Yes. Yeah, I got Big Sur. It's very cool. Oh, that's even bigger. Okay, so we have a mark, and let's say you're not doing very well right now. Let's say you have a 48 in computer science, and that's why you're here. Actually, hopefully you don't, because that would be kind of sus. But we want to see if you passed or failed. And so here's how we write the code for the if statement. So we first use this keyword, and that's if. And then we have a Boolean here. And so our Boolean, we mark is less than 50, right? And so here's our Boolean. And our operator is less than, and we're comparing the mark and 50. And so if your mark is less than 50, it means you failed, right? And so it's if Boolean, and then this colon statement is really important. And now notice this is something interesting. When you press enter, it actually enters with like 2 spaces, and that's called the indent. So whatever you want the code in your if statement to be, you need an indent, and then you do, I guess, print, you failed. Oh, I can't spell. Okay, right. Okay, so what do you guys think this is gonna print? Yes, it's gonna print you failed. Okay, and if we try it, wow, it printed you failed. And so this is what an if statement is basically. You write an if keyword, and then you check a Boolean. And if this Boolean is true, in this case, 48 is the mark, right? And is 48 less than 50? Yes, it is. And so it will print you failed. However, if this was, for example, like a 70, what do you guys think it would print? Nothing. And that is true. So when we run it, there's nothing there. And that's because the mark was 70, it was not less than 50, and so it did not execute this line of code. And that's basically what our slides say here. And so just important about the indent is you actually have to put the indent there, because if you don't, then first of all, like, you're gonna get an error. So like the code won't even run. But also, like, this code will basically not be under the if statement, which means that no matter the mark is less than or greater than 50, it will print this no matter what. And also, wait, you also said something about spacing, right? Yeah, so about spacing, as you can see, I didn't put the space between like this, wait a minute, between this and that, but like I could have, and like as you can see, wait, no, let's change back to 48. And as you can see, it runs now. So like you can have a space or not space here. Okay, what happens if you put 2? Does that still work? Wait, it does, right? What if I put like 10? Oh, it does work. Okay, I guess you can have unlimited spaces. So like you probably won't want to use like that many spaces. All right, cool. And so, okay, that begs the question. So like we're first checking like whether the mark is less than 50 or not. But what if the mark is more than or equal to 50? So like, let's just say 70. Our code wouldn't do anything, right? So how do we deal with that? So that goes on to our second concept, which is else. So it's kind of self-explanatory. It's like if this, then this, and if else, then do something else. So basically, if this first Boolean, which is marked less than 50, is not true, then we can have an else statement that will execute if this is false. So some, I guess, important things to note. The else statement must go directly under the if statement. So actually, let's just code this first. Okay, so let's just leave those spaces there for fun. All right, so we will have to actually go back to the first like non-indented block and then say else. And we actually don't need a Boolean condition for this because it's kind of like a catch-all. And then it'll print you passed. Congrats. All right, and now let's say the mark is 70. What will this be? Great, you passed. And so what this did was that the mark was 70, and it went through the first if statement. And it was, okay, wait, is this mark less than 50? So is 70 less than 50? No, right? So it'll go directly to the else statement, and I'll print you passed. And notice that, wait, does this work? Wait. Oh, you can have an enter line break, but don't do that. Just do this. Just for like good form. Okay, so yeah, it should go directly under. And also you can only have one else statement. So like, think about it. So like, let's say we have the mark is equal to 70. So if the mark is less than 50 and it's not less than 50, so go to the first else. So if you have a second else, then like the first else will catch it no matter what. So you can't like, it doesn't make sense to have more than one else. So yes. All right, and now like the final kind of piece of the puzzle is what if we want more than 2 cases? So right now we only have if and else, right? But like, what if like the user got perfect and we want to like give them like an extra like congratulations, you got perfect, right? But like right now we only have 2 cases, and so that brings us to our last sort of part, which is elif, or yeah, elif. That seems like the correct pronunciation. So elif is basically what we can put between the if and the else, and we can actually have like unlimited elifs. Like you can have as many as you want. And basically they're kind of like if statements, honestly. But you put the elifs after the initial if statement just to catch any additional conditions you want to catch. And yeah, its format is basically the same. So let's just go back to the example where we wanted to be like, okay, so like if you got 100, we want to give you an like extra congratulations. So we put it between the if and the else. And we return to the first like indent, or like the non-indent, I guess. And then when you say elif, it's actually kind of like else if, but then just put into one word. In some languages, it's actually just else if with a space. So let's say mark is equal to 100. Then I'll print Perfect. And so let's say we set the mark to 100. What do you guys think it will print? Yes, it will print the elif. It will not print 0%. Yes, so print perfect. And we could also have like more. So like elif mark is equal to 0, then print you did not do anything. And so if we do, actually that's kind of a bad assumption. Maybe you did do something, but oh, okay, wait, that's actually a good mistake to catch. Okay, so this is actually perfect. So as you can see, this code did not do what we wanted because we wanted to print you did not do anything, but it actually printed you failed. And that's because if elif else like statements, they work in a sequential order. So mark is equal to 0, and we go to the first if statement. And is 0 less than 50? Well, yeah, it is. So it's just going to print you failed. And after it print you failed, it's just going to just ignore everything else afterwards. And so it's not going to get to this part here, which is kind of a shame. But in this case, what we could do is we could do something like this. So we could move this part up to here and then change the mark is less than 50 into an elif. And so we basically just moved the mark equal to 0 to the very beginning so that it would catch it before it got to the 50. And now if you run this program now, it will print you did not do anything. And so yeah, that was actually a pretty good segue. All right, yeah, so then you can have as many as you want. And also notice that else is not required. So like if you have like, you can basically have if else, but you can also have if, wait, okay, so you can have just one if statement, right? So it could just be like this, and that would be fine. You can also have if and else. So you could have like if else, and you could also have just if and elifs and no else. So like this would work too. Like if you don't need that else like catch everything afterwards, then that is fine as well. And yeah, like as we mentioned before, in an if elif else, or in like honestly just any if statement, the first condition, the code will run for the first condition that is true, and I'll just skip the rest. All right, so right now we're gonna do an exercise just to like see that if you guys actually learned if, else, and elif. And so here is our exercise. So what we do is we're gonna have the user give us a mark, and then we're gonna give us a grade based on what mark they give us. So it's actually kind of an extension of what we just did here. So here are the conditions. And this is just like elementary school, honestly. So like if the mark is greater than or equal to 80, then we give them an A. And if it's greater than or equal to 70 and less than 80, we give them a B, and so on until it's less than 50, and then we give them an F. But in this case, rather than just like in these examples, we just kind of set the mark here, like, oh, mark is equal to 0. Cool. We actually want to allow the user to input their own mark. So at the very beginning of the program, you want to have the user input their own mark and then use that as the mark to evaluate on these conditions. And just a hint that the input like function accepts the user input as a string. So you need to remember to cast that as an int. And so yeah, all right, I guess I'll give you like 5 minutes or maybe like 2 or 3 minutes just to try that out. Lovely. Okay, we're gonna take this up now. So here's what your solution should have looked like. Something like this. So first we get our user input and we use the input function. So what that does is it actually gets our input as a string. And then we convert it to an int, and we use this by casting, which we taught last week, I think. Yes. Okay. And so that's our mark now. And now we just did what we did before. So if it's greater than or less than, or if it's greater than or equal to 80, we do A. So if mark is greater than or equal to 80, we print you got an A. And after that, we use the fact that because the mark is greater than or equal to 80, after this, the mark will be less than 80. So then if the elif, the mark is greater than or equal to 70, and because it did not go into this condition, it meant that the mark was automatically less than 80, and that would be a B, and so on until you got to elif mark is greater than or equal to 50, you got a D, and then everything that's under 50 would be F, right? So it'd just be else, print you failed. And you could actually do this the other way around. So you could start from failing and then go all the way up. But either of those work. All right.
You might have noticed that these if statements here use brackets. Just ignore that. That's like not necessary. Yeah.
Yes, Eddie is correct. I mean, you could include brackets, but it's kind of redundant, so you don't. All right, let's move on. Wait, Eddie, I think
so, yeah. So let's say you want to specify if if something is greater than 80 and less than or equal to 100. So you do this using Boolean operators, which are, and we're going to be focusing on and, or, and not. So think of them like the operators in math. So with and, there's two statements, two Booleans, and both Booleans need to be true in order for the entire statement to be true. Or only one of the Booleans needs to be true, and not basically like
Wait,
returns.
You can annotate.
Oh. And then not basically the Boolean needs to be false and it'll be true. And if the Boolean is true, then it'll return false. So like react or type in the chat what you think Boolean 1 will be. So
yeah. So basically not like basically if you the not is basically the opposite of the thing that it's after. So like you can just like ignore the not and then ask yourself, okay, is 2 greater than 2 greater than 3? And whatever you get, you just do the opposite of that. So yeah, what do you guys think that one is?
Kind of like saying if 2 is 2 not greater than 3.
Mm-hmm. But with enough knots, that could get a little complicated. Okay.
And yeah, that is indeed true.
What about
so Boolean 2 is not 2 less than 3.
Yeah. So basically like 2 less than 3 and then take the opposite of whatever 2 less than 3 is.
Yes.
Okay.
It is false.
Mm-hmm. Because 2 is less than equal to 2 is less than 3. And so that would be true, but then it's not true, so it's false.
Okay. So for Boolean 3, is 2 equal to 3 or false? So remember that only one of the Booleans needs to be true in order for it to be returned true.
Mm-hmm. So basically, like the only way to have something or something to be false is if both of them are false. And in this case, are both of them false?
Seeing many reactions, but yeah. It is false because 2 equals 3 is false and false is false. So yes.
Yeah, because none of them are true. So it would be a false.
So Boolean 4 is 2 greater or equal to 3 and false. So both of those two things need to be true in order for the Boolean to be true.
Yeah, so if for and, if just one thing as false, then the entire thing will evaluate to false.
So just looking at either of these, they're both false, so obviously. And then for Boolean 5, it's 2 greater equal less than or equal to 3 or true.
Just a recap for or again, that for or only one of them needs to be true for it to be true. So, and if both of them are true, then it's going to be true as well. Okay.
Yeah. I feel like it would have been a better example if one of them was false and one of them was true, but whatever. Okay.
That's true.
For 6, is car equal to truck and not true? So it's kind of confusing, but yeah. So again, both of these two things are false, because not true is false. Car isn't equal to truck. And then the last one we did a pretty easy one for the last one, but yeah, so
True or not false, and not true. What do you guys think that one is? Okay.
I'm actually I'm pretty sure that one's true, right? To just reveal the answers.
Oh, okay. Right. Yeah, it is true. Yeah, so I guess I think not takes priority, right? So like not false is true, and not true is true. So it'd be true or true and true, and then like any combination of truths without nots will just be true. So that is a true. All right, and just to like interject a bit, these logical operators and ors and nots are really important. Like you're going to be using them throughout code, like all the time. So like make sure that you really get it. So I know a lot of people can get like mixed up with the and or ors, like, oh, like why is it like two both need to be true for it to be and like only one needs to be true to be an or. You kind of think about it like English as well. So I don't know if it helps. Like if both if I am 16 and Eddie is 14, then both of those things are true, right? Like whenever you say and, like, but you're saying both things. So like obviously they're both true. And or like only one or the other has to be true. If you think about it in English, though I don't know if that helps. All right.
Okay, so we can rewrite the previous exercise we did to include the upper and lower bound. So what that means is basically you can check if it is greater than 80 and if it's less than 100 or something like that. So
yeah. Actually, let's just go through this part really quickly too. So actually, just like basically this bottom part. So like whatever these booleans are, right? Like something and something, or something or something, like that we can put as part of our if statement as well, because ultimately they evaluate to booleans. And so, for example, it would be like if Mark is greater than 70 and less than or equal to 80, you could add that in. So yeah, just do that for
yeah. Okay, so as you can see, instead of just checking if the mark is greater than or equal to 80, we also check if the mark is less than or equal to 100, and like for so on. So like if the mark is 487, like it won't print anything because that doesn't make sense. Yeah.
yeah. I mean, the solution is pretty self-explanatory. Is it okay if our solution is a little bit different? Well, what is your solution? or I mean, like as long as it like gets the job done, then it's okay. Like there's a lot of different ways to like write programming stuff. Like you could have flipped it around, right? Like you could have been like, oh, like if mark is greater than or equal to 50 and less than 0, then you failed, and just go like from up to down. Or like you could honestly put these in any order you want because there's an upper bound and lower bound. So yeah. All right, let's move on. Okay, moving into for loops. So like we said, this lesson is pretty packed, and it looks like, yeah, we always put it in the classroom. Okay, so mini exercise. Print the numbers from 0 to 10. It's like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just do that like right now really quickly. And react with yes when you're done. Yes. Right. Okay. 2 people. When does class end? Yeah, so probably gonna go a little over time today. But if you leave, that's okay. If you guys have to leave like early, that's fine, because then we're gonna be posting the videos anyways. But like right now, it looks like we're gonna take till like 4:20 at least, 4:25. Right. Okay, so yeah, sorry, Eddie, what are you gonna say?
No, never mind. Yeah.
All right, bye, Ryan. Okay, cool. So chances are you did like this. You did print 0, print 1, print 2, print 3, all the way to 10. Like that's kind of like the I mean, if you're new to programming, like that's all you know how to do, and like that's fine. Like that's basically the only way you would do that. However, what if it was like 0 to like 100, like 0 to like 1,000? And in that case, well, it wouldn't just take you like a minute, right? It would take you like hours, or like if it was like, let's say you had to like write like 1,000,000 print statements, that would take you years, or okay, maybe months. But like, is there a better way we can do this? And the answer to that is yes. So we can do that with for loops. So for loops is basically code that iterates or repeats for a specified number of times. And so basically, you're able to do something like this just in like 1 or 2 lines of code, because you basically just tell it to print a specified number of times and what to print for those times. And so the format is kind of like this. So for asserts a specified iteration, a colon, and code. So notice it's actually quite similar to an if statement. However, we're actually using an if for the for. And for an iteration, the iteration, it used to be a Boolean for an if statement, and now we're doing an iteration, so it's different. And so the first type of if statement is a range. So what the range is, let's just go over this quickly. So it returns a sequence of numbers starting from 0 by default, and increments by 1 by default, and stops before a specified number. So let's break that down. Basically, we have this range keyword, and we specify a number to stop at. And this number must be greater than the start number. So in this case, that's 0. So let's do this example here. So as we can see, we have our for keyword, and we have our iterator here. And within this iterator, we have a variable. And this variable is actually an iterator. And we usually use I, j, or k for this. And this is the big thing. So this is range. And here, our stop number is 11. And so by following the definition, it returns a sequence of numbers starting from 0 and incrementing by 1 and stopping before a specified number. And that number in this case is 11. So we start at 0 and we increase by 1 until we get to the number before 11. So it will be 0, and we increment by 1, so it's 1, and 1 incremented by 1 again is 2, and it goes 0, 1, 2, 3, all the way to just before 11, so it's 10. And so it's basically, for each iteration of the loop, I will take on the values from 0, 1, 2, 3, all the way to 10. And within each iteration, it's going to print the value of what this variable is. And in this case, it will just be the numbers from 0 to 10. So notice that it's actually what we just did, but it was just in 2 lines of code. And if we actually just try it out here, so I'm just going to delete this. Okay, so yeah, for I in range 11, print I. And if we run this right here, we'll see, wow, we have numbers from 0 to 10. And so this is what the range keyword does, is it just spits out this sequence of numbers from starting from 0, incrementing by 1 each time, and it stops right before the specified stop number, which is 11. And that's the most simplest form of range. So we can actually use this more complicated version. So we can actually specify what number we want to start at right before the stop number. So let's say rather than 11, we want to start at, rather than 0, which is default, we want to start at 5. So if we do that, then it will just print the numbers from 5, increment by 1, so 6, 7, all the way to the number right before 11, which is 10. And finally, we can actually specify a step number. So as you know, it by default increments by 1 each time. And so now we're actually going to increment, let's say 2. So what would that be? So rather than adding 1 each time, it would actually add 2. So it would be 5, 7, 9, and the next one would be 11, but we have to stop before 11. So it would just be 5, 7, and 9. And as you can see in this example, if you did range 2, 3, or 10, then it would be 2, you add 3, so 5, then you add 3, 8, and the next one would be 11, but 11 is more than 10. That wouldn't work. So you can either, there's actually 3, I think. Yeah, so you can either have just specify the stop number. You can also specify start and stop, and it would just default increment by 1, or you can specify stop, start, and step. And it's really important that the stop number is greater than, the stop number is greater than the start number. So for example, like, because by default we increment by 1, right? So for example, if we did like 15 and 1, then it wouldn't print anything, because 15 plus 1, 16, plus 1, 17, it's never going to get to 11. So that wouldn't work. However, if we made our step number negative, so this is a little more complicated now. Like if we made a -1, then it'd start from 15 and I'll increment by -1. So go down, so it's 14, 13, 12, and then stop right before it gets to 11. Yeah, so you could do quite a lot with range. And so yeah, this is actually like really useful, because if we know like something that we want to repeat, then we could just do it just in this range. And we also don't have to use this I. So for example, like let's just say we wanted to get input like 3 times, then we could just say x equals input, for example. Then it would just, we have to enter input 3 times. And so we don't necessarily have to use the iterator variable. Like if we don't use it, then it'll just run this loop a certain amount of times. But we could also use that variable. And yeah, and then moving on. So that is the range for loop. There's also the strings for loop. So when a string is basically like a sequence of characters, right? So for example, in LOL psych, it would be, the characters would be LOL space SYKE, right? And so when we say loop through strings, we basically mean that for every iteration of that loop, we get the characters of that loop. So let's just put that here. So dialogue equals lol, wait, okay, equals lol, what? Lol, psych. And then for char, actually character, or char works, I guess, in dialogue, then we print then we print char. And so basically, it's just going to loop through the characters and print them all at once. So in the first iteration, it's going to get the first character of lol psych, which is L, and it's going to print that. And then for the next character, it's going to print O, and the L, and so on until we get to the very end. So basically, we're using the same format as we did for range, but instead of using the range, start, stop, step, we just replace that with the actual string. And basically, in each iteration, we just get the individual characters of that string in sequential order.
Just a quick side note.
Oh, yeah, I took yours.
It's fine. Just a note for the example right here. He used single quotation marks for the string instead of double quotation marks. Both work the same. Like whichever one you use is just up to your own taste, basically.
Yes. All right. Sorry, Eddie. All right. Do you want to go over the exercises?
Okay. First exercise is to print the sequence from 5 12, 19, etc., all the way up to 705.
All right. Do we want to take it up now?
Sure.
All right. Actually, wait. I think it'd just be easier if I took it up on Replit.
Yeah.
Okay, so thanks. So for basically, if we do for I in range, so the first number is the start number. And so it starts at 5, right? And what's the stop number? So this is actually kind of tricky. Because if we say 705, and well, actually, let's just try that. 705. And then how much do we increment by? So the step is the increment, right? And so from 5 to 12, it's 7. From 12 to 19, it's also 7. So we increment by 7, right? And so then we print I. Okay, cool. But when we run this, we'll notice that it goes to 698. And that's because if we do 698 and we add 7, that takes us to 705. But when we specify the stop number, it stops right before that. So we have to say a number that's greater than 705, so like 706. Wait, okay, 706. And now when we run it, we get the numbers from 5, 12, 19, all the way to 705. Awesome. And we have 2 challenges here. But we're kind of running short on time, so let's just not do them. But you can go back and try them if you want. All right. Eddie, back to you.
All right. So you can actually put loops and if statements inside of loops and other if statements. So this is useful if you want to check for a condition, but only after another condition is true. So if you look at the code on the right, so you can try typing it out, but so, or do you have time? Or
Yeah, sure.
yeah.
Just like say the code as I type it and like explain it.
So we have 2 variables, taking test and mark. So for the first if statement, checks if taking test is true. And then we have another if statement inside of it. And notice how it's indented. So we'll discuss that a bit in the next slide. So what do you think it'll print right now? React in the React or type in the chat.
Anyway, I don't think you can react.
Oh yeah, we'll print out.
Maybe I should say yes and no, whatever.
Okay.
Yes, the people that type "no, buddy" are true, or yes, are right. Yeah, so basically, like what it is, as Eddie said before, you first, if it's nested, you have to go through the outer one first, right? So if test taking is true, and test taking is true, so we go into this, and now we start here. So is mark greater than 80? So is 69 greater than 80? No, right? So it goes to the null statement and it prints fail, buddy. Right.
Yeah. So in a normal if statement, the code that'll run if the if statement is true is indented. So then if you want to put an if statement inside of an if statement, you indent that if statement. So basically that makes like the if you are gamer, like that gets 1 indent, and then the code that'll run has 2 indents now. So as you can see there, and then you can just repeat that as much as you want to make your statements really meta. Yeah.
Usually you won't get to 5 though. That would be like some next level like program. Usually I think 2 or 3 is good. Depends on the actual program though. But yeah.
All right. So you can do the same thing with loops. So you can put loops and loops, if statements inside of loops. So we'll demonstrate that.
Let's just do something really quickly. All right, so for I in range, the multiplication table, I guess. Wait, Eddie, how do you do a print statement without a how do you do a print statement without a new line? There's a way to do that, right?
Right.
That, right?
Oh yeah, you can specify the end. So set n equals nothing.
And then there's print. That works. Okay, so here we're basically trying to make a multiplication table of 5s. That works. That's going to be a fail, or it's going to be... Wait. Does it not work? Wait, what if I just do space here? Rip.
Wait, I'm pretty sure you put like n equals nothing.
Oh, n equals, right. Genius. N equals. Oh, it's not set. Yeah. Oh, okay. Yeah, cool. Yeah, so basically this is like a multiplication table of 4s, right? So 0 times 0 is 0, and then 1 times 1 is 1, 1 times 2 is 2, so on until we get to 4 times 4. And that's something we could do with nested if statements, and nested loops. And don't worry about this stuff. We just made it like to make it look pretty. But yeah. Oh, wait, should we put like an if statement here too? Oh, we could. So if like j is equal to like 4, I guess. Now we could do print that. Now I should run the same. Yeah. Here, Eddie, do you want to like explain this code really quick?
Sure. So first it goes for I in range 5. So first I is equal to 0, and then j is equal to 0, and then it prints the two multiply each other. So then, and then next j goes up by 1. So then I is 0 and j is 1, and prints that, and then and so on until j is equal to 4, and then after that j goes back to 0, and then I goes up by 1. So like each I gets multiplied by every j, basically.
Yeah, it can be a little bit confusing to wrap your head around. But think about like, so basically all this is run for every iteration of I. And all this is run for every iteration of j. So basically this thing is going to get run like 25 times, but with different values of I and j. All right. Okay, so moving on to while loops. So here's a different type of loop. So it's not for anymore. We're actually using the while keyword. And so unlike for loops, while loops actually keep going until a condition is false. So it's actually kind of similar to the if statement, in which we have while a Boolean. Actually, wait, this should be a Boolean. Yeah, so while a Boolean, a colon, and then we have code. So let's just look at this one right here. So what we have here is, I'm actually just gonna try to think about what this code will actually do. So as you can see, it printed the numbers from 0 to 10. And that's exactly what our for loop did like a while ago. So I just break this down. So we start at x is equal to 0. And we have a while loop here. And so this while loop, we specify with the while keyword. And we put a Boolean here, and we have a colon. So while this Boolean is true, whatever is in this while loop will keep executing. So x is equal to 0. Is 0 less than 11? Yes, it is. So it's going to execute whatever is in here. So it's going to print x is 0. So it's going to print 0. And we have this funny little line here. And we have x is equal to x plus 1. So actually, mathematically, this would not make sense, right? Because like that would mean that 0 is equal to 1, which is not true. But this is programming here. And equals is a declaration statement. So x is 0. And we're saying x is equal to 0 plus 1, which means that x is equal to 1. So we're basically increasing the value of x by 1. And then we go back again. Okay, is 1 less than 11? Yes, it is. So we print 1. And now we set x is equal to x plus 1, and x is equal to 1. So x is equal to 1 plus 1, which is 2. And now we go again. So is 2 less than 11? Yes, it is. So if you think about it, it's just going to print 0, 1, 2, all the way until it gets to 10. So x is now equal to 10. We print 10, and now 10 is equal, and x is equal to 10 plus 1, which is 11. Now we go back again. And is 11 less than 11? No, it's not. So it's just going to jump out of this while loop and onto whatever's next, which is nothing. So the program stopped. And so we actually have this interesting thing right here, which is the break keyword. So what this break keyword does is that in a while loop, whenever this code, the code in here hits this break keyword, no matter what it's doing, it's gonna pop out of this while loop and move on. So let's say we want to stop at like 5. So if x is equal to 5, then break. So basically, once x is equal to 5, it's just gonna leave the while loop. So as you can expect, it's just gonna print the numbers from 0, 1, 2, 3. Oh, okay. Okay, this is interesting. Okay, so basically, it goes from 0, 1, 2, 3, 4. And so we print 4. 4 is equal to 4 plus, x is equal to 4 plus 1, which becomes 5. And now that it's 5, it just leaves this while loop and it moves on with its life, whatever. And so now it's actually never going to get to print 5. And so that demonstrates what the while loop, what the break or keyword does. And so moving on, so we actually have something called infinite loops. So break, yeah, I guess you could say it means stop, as in like it stops the while loop, yeah. But I guess break is just the keyword for like breaking out of the loop, right? So we actually have something funny where, unlike like range loops where we can specify like where to stop and how many times to like go through, like iterate, we can't do that with while loops, right? And so with while loops, we could actually have these things called infinite loops in which this condition just is always met. So it just keeps going until like literally forever. So let's say we print x, and instead of doing x is equal to x plus 1, we do x is equal to x minus 1. And if we run that, it's just gonna keep going until my program crashes. And I guess we're not gonna crash greplet though, but it's just gonna keep on going. And it's never gonna stop because here's what we're doing. So we have 0, right? And so is 0 less than 11? Yeah, it is. So it's gonna print 0. And now, okay, I should probably stop. It's gonna kill my, okay, so we have x is equal to x minus 1. So x is equal to 0 minus 1, which is negative 1. And is negative 1 less than 11? Yeah, it is. So it's just gonna keep going. And since we're decreasing the value of x, it's always gonna be less than 11, which means that it's just never going to stop. And the thing is, infinite loops are very bad because they never stop and your code doesn't do what it's supposed to do. Unless you do want to crash your code. That usually isn't the case. So in this case, the break statement is actually really useful because then you can break out of this infinite loop. And so if you like figure out like your program like just never stops running or something, you probably have an infinite loop somewhere in there. And just a little, oh wait, we might actually finish. Okay, so now we have 2 loops, right? We have the for loop, which is this guy up here. And we have actually 2 types of for loops, right? So we have the range type for loop and we have the string type for loop. And we also have the while loop. So that is here. And now you might be thinking like, which one do I choose, right? And so here's how you decide which one to choose. All right, bye, Matthew. He has been keeping you guys for quite a long time, actually. But you're still here, actually, which is pretty solid. Staying after on a Friday. We commend you for your dedication to computer science. But anyways, so use your for loop well, you know exactly how many times you have to do something, right? And basically, let's just say you want to loop through something like 11 times, you use a for loop because you can specify exactly how many times you want to do something. Or if you have like something really specific that you want to do, like looping through like a string, we're going to get into like data structures later, which is like lists. If you want to loop through a list, you would use a for loop for that. So basically like doing something a very specific amount of times. Meanwhile, with a while loop, with a while loop, you'd use it when you don't know immediately upon entering the loop how many times you're going to have to do something. So for example, like a game loop, like you want to ask the user if you want to play again. Well, what if the user wants to play again 2 times? What if they want to play again 200 times? In that case, you would use the while loop. Also validating user input. So like you want to see like, oh, like we want the user to click yes or no. And if they don't click any of those, then we have to wait again. So those are cases for while loops. And both are very important. You're going to use them a lot, both a lot in the whole, I guess, computer science, all of that. Okay, and now we are on to our final exercise. So this is actually something that's pretty fun. Wait, I'm doing this right. Yes, so this game is the guess the number game. So what this program does is that first, upon entering this game, the computer picks a number. And then you have to guess it. So you say 50, the computer says too low. You guess higher, 80, well, it's too high. And all the way until you get the right number, and then the computer tells you how many guesses it took you. And then it asks you if you want to play again. So let's just go through the instructions right here. So if you want to make this game fun, you want this number to change every single time you play this game. And for that, we'll have to use the random package. So we actually haven't learned it yet before, but don't worry because we're going to teach how to use it. So at the very top of this file, you're going to write these keywords, import random. And then every time you want to get a new number, it will just be whatever this number is equal to random.randint. And in these two brackets, you specify the smallest number the random number can be and the largest it can be. So let's just say we want to do 1 and 100. And let's just say I print this number just so we see what it looks like. So when I run this code, what is it going to give me? Wait, do I need to refresh this? Oh, okay, it gave me 70. And as you can see, that's between 0 and 100. But like, if I run it again, it's going to give me a different random number, right? And that's what we want. Like, we want the number to change every time so the game's actually fun. And so just remember to do this at the very top. And every time you want to get a random number, you just declare it to be random.randint. And between these brackets, put the smallest and largest number. And so here's how like this whole thing is going to work. We're going to have a general game loop, right? So you're going to want to every time, and remember we said that the game loop is usually like something like a while true. So you might want to start it off like while true, and then we want to generate this number. So I guess this number would be right here, right? And after that, we would want to ask the user numbers every single time. And if the number is too high, we tell them it's too high. And if it's too low, tell them it's too low. So just a hint, do you know how many times the user is going to guess? No, right? So you might want to use a while true. And so, yeah, that is basically the challenge for this week. We probably won't have that much time to go over it, but we do have the solutions. And we also have some additional challenges for the people who are more advanced here. So you can, at the very end, when the user finishes, you ask them if you want to play again, right? And so they can either write like what, yes or no. But like, what if the user doesn't type any of that? Well, then an additional challenge would be to keep asking the user to enter either yes or no. And if they enter it wrong, just keep asking them again. And also, you can instead of doing too high or too low, try giving more detailed answers. So you could be like warm, warmer, warmest, like hot, cold, colder, stuff like that. And also, this isn't like related to coding, or I guess it is, but like not like it won't be something the computer will be doing. But can you think of the optimal strategy to guess the number in the fewest number of tries? And so this will be for a homework because we won't have time to cover it today. We'll probably cover it in tomorrow's class though. And yes, Eddie.
Yeah, so.
Sorry. Oh.
Yeah, so you can finish that random number guessing game on your own time. And so another optional project is making a rock, paper, scissors game. So, and the solutions are on the slides, which will be posted on the Google Classroom. So also need a random package for that. And practice. I know this lesson was really jam-packed with a lot of important stuff. So I definitely recommend going to these links and practicing a bit. And if you have questions, go to our Discord and ask in the Python help channel.
Right.
What?
Yeah, because like Eddie said, we went through this stuff really fast. And this stuff is actually like, if you were taking like a computer science class right now, like you'd probably spend like a week to 2 weeks on this. But we don't have a lot of time, so we went through it pretty quickly. So please try at least this exercise. And if you like can't figure it out, then ask in the channel because our execs are really happy to help. And this stuff is also really important And if you want to be able to build games like Battleship, Tic-Tac-Toe, like Hangman, like whatever, like you're gonna need this stuff for sure. And later in your future for computer science, like this is gonna be like the most fundamental things you're gonna learn. So please make sure that you're trying these, and if you have extra time, then you're doing these exercises. And oh yeah,
Just smash subscribe. According to the charts, only 10% of you are subscribed watching right now. So yes, we're trying to hit 100 subs. So yeah.
I mean, technically we have like 69 million, so I don't think we really need your subs, or 69,000 million or something. So I don't think we need your subs, but if you do want to like catch up, and like if you think you missed, oh shoot, do we record this?
Yeah, I'm recording right now.
Okay. Yes. So yeah, like also people, if you know anyone who's like not like who's unable to come on Friday, so they can look at our videos too and learn as well. And then we have these additional resources. So if these are, so CS Circle is actually a really good site. Like if you if you weren't able to like find like our lesson like understandable, and you like don't really want to talk to the execs because I don't know why you wouldn't, but these sites are very good to like learn the material on your own, or just like learn them in a different way. So like these are the stuff on ifs then booleans, and these are the stuff on loops. And it's kind of just like an online course, kind of like Code.hs, but it's free. And yes. All right. Well, thank you for coming and staying for 30 minutes past the actual time. But yeah, that is it for today. And hope you guys have fun making your guess your number games. Oh, wait, Eddie disappeared. Oh no.